From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker. Welcome to the show. This episode of Fragmented is brought to you by Hired.com. I don't know about you, but looking for a job kind of stinks. It's never really a good time, but Hired.com kind of makes that process a little bit easier and a little more rewarding. If you go to Hired.com/fragmented, they'll actually pay you a $2,000 bonus if you land a job through Hired.com. That's double their normal bonus of $1,000. So a couple cool things about them. They actually will provide you the salary information up front to all of the positions. You can select the type of job that you're interested in applying for. So maybe it's a cool, scrappy startup. Or if you're really into those big corporations, you can check out a nice, big, cushy corporate job as well. You get to decide. It's up to you. The salary information is presented to you up front, so you can make sure that you're not wasting time with an interview that ends up being for no because you don't like the salary. There's also a whole bunch of other great things, such as you can apply for jobs in engineering, marketing, design, you name it, they got it. Again, if you're interested in finding a new job, be sure to check out Hired.com, and that's go to Hired.com/fragmented to lock in that $2,000 bonus. Thanks again, Hired. Now, before we get started, I want to say thank you to everyone out there who's been listening to the show, to all the people who participate in our Slack channel, who everyone just sends us comments on Twitter and all the various locations and Google Plus, and when we see you at conferences and you have nothing but great things to say. We want to say thank you to all of you for listening. We are very honored that we get to spend the time inside of your earbuds. We know that every moment of life is precious, and the fact that you spend some time with us every week and listen to us babble on and hopefully learn something is tremendously valuable to us. So thank you all for listening this much and continuing to listen. Now, as usual, if you have any feedback that you would like to provide to us, you can always reach out to us at fragmentedpodcast.com/contact, and you can email us directly there. That'll go to directly Kaushik and I to our direct emails, and we can reply to you from there. If you'd like a quick reply, you can hit me on Twitter at Donn Felker. Kaushik is at Kaushik Gopal, also on Twitter, and we have a Fragmented podcast Twitter handle, which is at FragmentedCast. Any one of those ways you can reach us. We love any of the feedback. If you have questions, you like show requests, anything of that nature, we take all that to heart. Lastly, if you do really enjoy the show, we just would love to ask a favor of you, and that favor would be to open up that horrendous interface called iTunes, sign into it. I know it's painful. If you could just leave us a review on there, it helps us out a lot, even though the majority of you are Android developers or Android professionals in one way or another. Leaving a review on iTunes actually helps our podcast quite a bit. So anything that you could do in that regard, we would really, really appreciate it. And I did mention we do have a Slack channel. If you go to fragmentedpodcast.com on the left-hand side or in the menu, depends if you're mobile or not, you will see a link for our Slack channel. You can go there, sign up. It's free. Kaushik and I are in there on occasion when we have time. There are a lot of other folks in there that are helping each other out. So if you have questions about the show, anything that happened, want to make requests, want to say hi, or maybe you just have a problem you're trying to work through, you can kind of hop in there. Now, it's not a replacement for Stack Overflow. Stack Overflow is going to probably be the best location you can go to for the various different questions you have, but check that out anyway. All right, so for those of you who have been listening, you're probably familiar with something that we started way back in the beginning of Fragmented, and that was the series on basically effective Java. If you're not familiar with Effective Java is a book written by Joshua Block. It contains a wealth of information about best practices around Java development. You would be surprised at how much you didn't know through the process of reading this book. And I know that's the way that I felt. Every time I get to a new section, I thought I understood how something worked inside of Java, only to be surprised that I absolutely have no idea that this one thing I thought worked one way, worked a completely different way, or was just kind of halfway in the middle broken, or what it seemed like. We have covered 10 of these different items from the Effective Java series. It's been a while since we've covered another one. I'm going to continue covering these. As well as Kaushik is. And today we're going to talk about item number 11 from the Effective Java book. In item number 11, the title of it is Override Clone Judiciously. Let's dive right into that and see exactly what that means. Now, the clone method, when you override it, it's actually based upon the Cloneable interface. And it was basically intended to be some type of mix-in interface for objects to advertise that, hey, I can be cloned, which makes kind of sense. We always want to take a copy of an object and do something with it. But unfortunately, the way that it's implemented is really awkward and it doesn't really do what you think it does. So hopefully I'll try to explain as best I can through this audio conversation with you here. Hopefully I'm able to spike enough interest that you actually either open this book if you have it or go pick it up. It's really important to understand how clone works because it can come back to bite you later on if you don't know how it works. So here's the thing is, clone is based upon the clonable interface. And the primary failure that the clonable interface has is that it does not contain a clone method. It's just this interface. Without resorting to reflection, you cannot invoke the clone method. The clone method is actually on the object class. So way up in the object hierarchy, there is the clone method, and it is protected. The way that this works is kind of weird under the hood, and that's what we're going to dive in here. Again, we can't invoke it unless we're diving into reflection. So how do we invoke this method to actually start cloning our object? I think before we can really answer that question, it really beckons the understanding or beckons the need to understand what does the clonable interface actually do, given that it really doesn't have any methods. Now, in short, what it does is it determines the behavior of the actual Java objects, and that's the actual Java object class. It's protected clone implementation. So it determines that behavior of what it's going to do. And now if a class implements clonable, the Java object's clone method will return a field by field copy of the object. Otherwise, it's just going to throw a clone not supported exception. Now, this is very atypical for interfaces because normally when you implement an interface, it says something about what a class can do for one of its clients. So you may be saying, hey, I'm going to implement some type of provider interface, and you're going to provide some type of information, and how that's going to happen is dependent upon the implementation. It's not that way here with the clonable interface, because just by implementing the clonable interface, we are then telling how the object.clone method is going to work. So everything is kind of atypical in this situation of how the actual operations work. Now, it even gets more furtherly complicated because if we're implementing a clonable interface and it's to have any effect on that class, the class and all of its superclasses must also obey this fairly complex but very unenforceable protocol of making sure that you override the clone method everywhere so you make sure you get the object that you're expecting back. So I know this is confusing sounding, but hang in there with me. So here's the thing that's to even add to more confusion for you is the resulting mechanism, and this is a word directly from the Effective Java book, actually a quote here. It says, the resulting mechanism is extralinguistic. It creates an object without calling a constructor. Now, the Java specification states that the clone method basically is as such. It creates and returns a copy of this object. The precise meaning of copy may depend on the class of the object. The general intent is that for any object X, the expression x.clone will not equal x. Now that will be true, basically saying, hey, if I clone myself, I'm not going to be equal to my clone. But the expression of, hey, x.clone.getClass will equal whatever the clone's class will equal whatever I cloned. So if x.class equals clone.class, that will resort to be true. But that's not absolute requirements because there's also things that state that x.clone could also equal its equivalent. So there's a whole bunch of different semantics that are happening with this clonable interface. And there's a bunch of different problems that we have here. And one of those is that the problems that is had is that no constructors are called. So how does this happen behind the scenes? Now, how this happens behind the scenes is that the object.clone does all of the work for you. So if you're going to implement clonable, you need to make sure that when you are actually going to actually honor this, you need to override the clone method. And inside that clone method, you need to actually call super.clone. So you're going to override the clone method. And then what you're going to do in there is you're going to go ahead and return super.clone. Basically, if you override the clone method in a non-final class, you should return an object obtained by invoking super.clone. Now, if all of the classes implement the super.clone methodology, then everyone else will eventually reach all the way up to the object.clone method, resulting in creating an instance of the correct class. Now, if you were actually to call the constructor on an object and it had other parent it had other superclasses, the clone method would never be invoked at the higher level. So you can't, inside of a clone method, you can't invoke a constructor. You actually need to call super.clone, so it starts walking up the object hierarchy, calling clone on each one of those. Now, each one of those parent objects also need to implement cloneable correctly. Now, if there's any break in the chain there, then the eventual object.clone is not going to get called. You're going to retrieve a object that you may think is a copy, but could actually have shared state across two different objects. So if you change an array value on the cloned object, it will actually change it on the object that you had cloned it from, creating a big, huge mess of inconsistencies across your application. Now, in practice, a class basically that implements Cloneable is expected to provide a properly functioning public clone method. Now, as I just stated before, it is not in general possible to do so unless all of those superclasses also implement a well-behaved clone implementation, either be it public or protected. They all have to be well-behaved and designed correctly. Now, let's take this a step further. Let's assume that we have, speaking of mutable state, let's say that we have a class like the stat class in Java. Now, the stat class has some other information inside of it, such as, an array of elements that it's going to be working with. If we were to implement cloneable on that and its clone method, just merely returning super.clone would actually result in an erroneous implementation of clone. And why is that? Because at that point, we'd actually just be sharing the mutable state because the elements would now be shared between both of the instances. So to do that, what we'd actually have to do is actually hop into that elements array and make sure that we're completely copying all of those objects over and over and over into them. So we'd actually create a new array and load those new values in. So we'd basically have to loop inside of that array to get those values, put them into the new cloned object. So we actually do have its own independent cloned object, and it's not sharing shared state. So at this point, we need to make sure we understand how our object is built, how the objects above us are built. So if we are extending a class and it maybe has shared state, is it implementing cloneable correctly? Or is it implementing the clone method correctly? We need to make sure that we're implementing the clone method correctly. Do we understand everything our class is doing? Do we have anything that could be shared state? Do we have a map? Is there an array somewhere? Do we need to make sure that each one of those objects are calling clone correctly? Because if we don't, we could end up in these weird situations where null pointer exceptions start happening because items were removed or things are indexed out of bounds, and we get other types of exceptions. So there's all different types of things that can happen, and of course, your application running at runtime on a mobile device. All different types of things could happen, and then before you know it, you got crash reports that are very confusing. Simply because of a poor understanding of the clonable interface. Now, there is also a problem with the clone architecture. It's incompatible with the normal use of final fields, referring to mutable objects. So if you have, let's say, an array of objects and that's marked as final on the field, well, we can't, inside of the clone method that we implement, create a new instance of that. It's just not going to be allowed. So in order to properly implement clones, sometimes you actually do have to go remove the final keyword, which a lot of you are probably gasping right now, like, what? There was no way I would ever do that, which kind of brings me to the point of cloneable is seen as a lot of professional programmers as something that they stay away from. Now, why stay away from it? Well, let's just recap for a second and talk about this. So all classes that implement the cloneable interface should also implement a clone method that's public and who has a return type of itself, of the class type. Now, this method should first call that super.clone method, what we talked about before, and then fix any fields that need to be fixed accordingly. And this usually means that you're going to copy any of those mutable objects you have lying around and basically create a big, deep copy of the object that's being cloned and so forth. Now, we also need to make sure that each of those mutable objects are implementing clone correctly themselves and up the hierarchy as well. As you can see, this kind of spider webs out of this one little object that you maybe are using a couple different types inside of and you want to create clone. Now that may spider out to 30, 40, 50 different places because of this one clone implementation. You need to make sure that clone is implemented correctly all the way up. So is this complexity really necessary? And this is exactly the thing that Joshua Blocks asks in the book. Is this complexity really necessary? Now, it's kind of rarely necessary. However, if a class implements cloneable and it is well behaved, you basically, you have little choice but to implement a well-behaved clone method yourself. Otherwise, there are a couple of other options, which can also create this copying type of capability. So what are these couple of options? The first option is to provide a copy constructor. And that's basically a constructor that takes in the type that you have. So let's say we have a potato class, and then I want to create a copy of the potato. So I'll say public potato, and the only argument is another instance of potato. And then from that point, I can actually go inside and manually create a copy of it myself, because that's how I know how it needs to be created. The other way is to create a copy factory, and that's very similar to how we have seen other types of static instances being created. So we'd actually say public static potato new instance. So you're probably familiar with new instance from Fragments. So it's a very similar type of pattern here, except for the new instance method would take in one parameter, and that would be the potato itself. And then in there, you would go ahead and create the potato, copying all the necessary fields and mutable objects accordingly. Now, why would you do that over using clone? Well, because you control the complete way that it's actually implemented. You're not relying on some extralinguistic object creation mechanism that you need to make sure you understand all of the hierarchy. If you actually go to Stack Overflow and just look up or even Google this Java object clone, you'll see a bunch of confusion where folks say, hey, I created this object and I cloned it, but it seems to be this shallow copy. Like, it's not a real copy. Like, what's going on? And then what you'll actually see folks do is reference, hey, clone does not work the way you expect it to do. It's very poorly documented. It's probably not written well. It's not something you should model any of your classes after or any of your inheritance structures after. Furthermore, to really get an understanding of it, go take a look at the Effective Java book and read the clone part, which is what we're covering today, item number 11. Now, furthermore, if you want to build your own different type of copy constructor or copy factory, you can do a bunch of different things. So instead of actually taking in the actual type of class, you could implement some type of abstraction. So you could say, hey, a new potato, and you could say, type of vegetable, and it's just going to copy that vegetable based upon a potato, whatever. Now, that example may not make that much sense, but you can kind of see what I'm saying, that you provided a lot more functionality and a lot more freedom when you start implementing your own copy implementation or your own clone implementation and not relying on Java's implementation. And I'm going to wrap this up by almost reiterating the exact last paragraph of the item number 11 in Effective Java. And Joshua basically says that given all the problems associated with Cloneable, it's probably best to say that you should not extend it. And that classes that are designed for inheritance should not implement it because of all these crazy complexities. Now, I talked about some of the complexities here. There's even more listed inside of the Effective Java book here. He dives into some examples of like, all right, well, you're going to have this hash table and maybe you have this phone number class. And here's how you could run into a weird situation here because someone has created their own performance induced linked list. And this is where you're going to run into a problem here. And you got to make sure you cover this edge case and this edge case. And there's just edge cases abound when you implement Cloneable. Going back to the last paragraph here, he actually says, because of its many shortcomings, some expert programmers simply choose to never override the clone method and to never invoke it, except perhaps to copy arrays. But there's also other ways to do that as well. Now, if you design a class for inheritance, be aware that if you choose not to provide a well-behaved protected clone method, it will be impossible for subclasses to implement Cloneable. So that is the one downfall that you need to be aware of not implementing Cloneable and doing it yourself. If you don't do it, anyone else who extends you cannot possibly implement Cloneable effectively. Now, I'll leave that up to you to decide if that's a good thing or a bad thing. For me, it seems that I would possibly go ahead and write my own copy implementation using either a copy constructor or a copy factory, as it seems a little bit easier for me to A, unit test, B, to understand. I want to make sure that when I'm looking at code and I know the other developers that I'm with, we want to be able to look at this code and understand it and not have a bunch of weird black magic happening in the background. Cloneable is one of those interfaces that you think you know what's happening, but you really don't. And there's kind of this veil that's pulled between us that we kind of have to understand what's happening in the background. Item number 11 of the Effective Java book really explains it well, but sometimes you just need to step to the side and create something that works and kind of just keep it simple. Now, I hope that helps. And we'll be talking about item number 12 in one of our upcoming fragments, which is going to be consider implementing comparable, which will also be very interesting. Well, that wraps it up for today's show. If you'd like to reach out to us, you can reach out to us on Twitter at FragmentedCast or send us a message at fragmentedpodcast.com/contact. If you want to reach me, you can hit me at Twitter at Donn Felker. You can also talk to Kaushik on Twitter at Kaushik Gopal. Fragmented is hosted by Donn Felker and Kaushik Gopal. We edit all of the Fragmented episodes ourselves. The amazing Sarah from the Spec Fragmented.fm network helps us with production assistance and unwraps our final mix. So special thanks to her. Our theme music and ad music is by Alan Taylor. You can find more episodes of the show on Pocket Casts, on Google Play Music, or any of the Pocket players in town. But we do have to say, we love Pocket Casts. Our website is fragmentedpodcast.com, and you can find the links and all the show notes for the stuff we say on that website. Thank you all for listening. We'll catch you in the next episode. Before we get jamming out of here, I want to say thanks again to Hired.com for taking their time to sponsor this episode. If you're out there looking for a job, for a change of pace, definitely take a look at Hired. They got all kinds of cool stuff out there. And if you go to hired.com/fragmented and land a job, you'll get hooked up with that nice, cushy $2,000 signing bonus. That's right. $2,000. Sounds good. Thanks, Hired.